Welcome to my CompTIA Security Plus Guide to Network Security Fundamentals 5th edition. Here we're looking at Chapter 12, Authentication and Account Management. So, we're going to describe the different types of authentication credentials, explain what single sign-on can do for us, and some of the pros and cons for it. We're going to look at the different account management procedures for securing our passwords as well. So, authentication credentials normally fall in a few different categories. The common three are what you have, what you are, what you know. What you have, something that you physically have, like an ATM card or a CAT card. What you are could be like a biometric, fingerprint, palm print, facial recognition, or iris scan. What you know is going to be like a password. The other two are so-so. Where you are, that could be based off of location. And then lastly, what you do. And that's something that to prove the authenticity. So you can say that you do a specific task, and so you do that task. And there are people out there that say that, well, that's something that you know, and granted, yes. So the common four are have, are, know, or location. Authentication credentials could be things like a key fob, what he has, again, facial recognition, combination. Here, what he does could be a task. So what you know, again, password, username. Password weaknesses are in memory of an issue. If it's too long or too complex, we may write it down and that's easy to find. We may use passwords that are easy for us to remember, but for other people to easily guess. Typically, password policies will control when the passwords expire. Users often take shortcuts, so they'll use weaker passwords or reuse old passwords. That's why password policies need to be enforced. Weak passwords like 123456. That's a common one. Password, I love you, princess, and so forth. There are several types of attacks that can happen on passwords. Social engineering, that's where people try to socially gain your password through phishing or watching your shoulder or looking at your desk for a post-it note that says password. There's also called capturing, and that's going to be like a keylogger or protocol analyzer. Maybe even be a man in the middle. That way they can capture your password as it's being sent, or resetting. And that's typically where the attacker will gain physical access, and then they just reset your password on your machine. Other types could be offline cracking. That's where they actually gain the hash of your password, and then they try something like brute forcing it, trying several different combinations to guess your password. We also have things like automated brute forces, and that will try like patterns, it will try things that are common to a user. This is more complex because the program would have to know about the individual they're attacking, so more often than not these brute forces will do common passwords. We also have what's called a dictionary attack, and that's where they start trying common words in the dictionary. Here's an example. We have a dictionary word. It will create digests, and it will try all the different types of digests. And these word lists will get larger and larger and larger. That way, you can try multiple millions, if not tens of millions of potential passwords. Because that's the thing is, all we need to do is get a hash that's similar or a hash that it accepts it. Then one of the problems with this is, if we do not have a password lockout policy, you can keep trying this type of method. However, if we do have a password policy that says 3 failed attempts and your account is locked out over the course of 5 minutes, these types of attacks are kind of mitigated because these attacks require, thousands of tries of passwords, and if we're limited to 3 passwords every 5 minutes, then it makes it a lot slower. We have what's called the pre-image attack, and that's where a dictionary attack that uses a set of dictionary words and compares it with stolen digests. We have a birthday attack, and this is the search for any two digests that are the same, trying to match the two. Remember that the digest is typically a password that's gone through an algorithm that is hashed. And then no two passwords should have the same hash unless the passwords are identical. So you can have things called like a rainbow table, which is actually a pre-generated data set of possible hashes. So example, the rainbow table will have common passwords like password, password1. They'll have those hashes already calculated. So all you're doing is comparing the password hash that you have to a known table of hashes to kind of see if they work or not. They're the hybrid attack, which is a combination between a dictionary and a brute force, and they do slight variations of the dictionary just in case people are fat fingering those words. Steps for using a rainbow table: typically you create the table. It's a chain of plain text passwords. You encrypt the initial passwords, you feed it into a function, and repeat. You're using the table to crack passwords. And in all honesty, you're not going to do this yourself. You're probably going to find the predefined rainbow table word lists or lists out there that have already been calculated for you. So using the table to crack a password, you're going to, again, go through the process of matching your hash with known hashes. Benefits is this is repeatable, it's faster, and uses less memory and less overhead. Password collections. There are hundreds, if not several 100 million passwords out there that have already been stolen and published every year. Password masks attack a significant reduced the amount of time needed to break passwords. Password mask attacks. This kind of is compared to the brute force attack. In all honesty, password policies that are good and user training that are good kind of defeat these types of attacks. 4 primary defenses: complexity, management, hashing of algorithms, and salts. Password complexity, making a more complex password. Most passwords consist of a root or an attachment, either be a prefix or a suffix. The attacking program's method will test passwords against 1,000 common passwords typically, and kind of give up after that. But again, if there is a lockout policy, this is neglected. Combines common passwords with common suffixes, then that uses dictionary words. You slowly start seeing how these word lists get larger and larger. And then you can start substituting special characters like $sign or @ signs for like S's and A's, and then again it grows and it grows and it grows. General observation about created strong passwords. If you have 95 keys on your keyboard and your password length is 2, there are over 9,000 possibilities. If your password length is 3, you can read the slide 4, 5, 6, and so forth. So normally you want a 8-character password that's not an easy to remember or easy to guess password, but it's something that's going to be easy enough to remember so that you don't write it down. Not too easy to remember, because if you can remember it, it's probably easily guessable, so keep that in mind. Credential management, basically making sure that you remember your password without having to write them down everywhere. So again, this is going to be against theft and digest files. Don't leave your computer unattended. Screensavers should be password protected. The boot sequence should also have a password protection, and so forth. Good password management practices: change your password frequently. Don't reuse passwords. Never write down your password. Use unique passwords for each account where possible. Set up temporary passwords for other users' access. Don't give them access to your account. Don't allow computers to automatically sign in to an account at all. Don't enter passwords on publicly accessible computers. Never enter a password while connected to an unencrypted wireless network. Password management applications, use them after you've done thorough research so that you can have your passwords protected. Common password hashing algorithms in Windows, we have LM, LAN Manager, or we have NTLM, which is a new technology LAN Manager, and these are the hashing algorithms used to encrypt the passwords. LM hashed passwords are very easy to break. Key stretching is a hashing algorithm that requires significantly more time than standard hashing algorithms to create the digest, but are more secure. So salts. What is a salt? Salts consist of a random string that is used in a hashing algorithm. The passwords can be protected by adding a random strong to the user's clear text password before it's hashed. So it'll be the password plus the salt hashed will get the salted hashed password. This makes dictionary attacks and brute force attacks much slower and limit the impact of a rainbow table. Because again, the salt will be a random text added to the end of a password. Example, here we have Apple, we have the unsalted password hash, we have random salts, we have the salted password, now we have the salted password hash. Because it would be the random salt plus the password, that gets us our fourth column, and then the salted password would also then be hashed. Multi-factor authentication, using several factors to authenticate, as opposed to single factor, which is just one type. Something you know, something you have, something you are. Multi-factor is typically 2 of the 3. Single factor is typically 1 of the 3. So what about what you have? Things like tokens, cards, cell phones. So a token is a small device, typically with a window display, that will use a one-time password or OTM or OTP. There are 2 types of OTPs, time-based and one-time passwords. That will be a TOTP. It normally syncs with an authentication server. Code is generated from an algorithm, and the code changes every few seconds. Here's an example. We also have what's called a HMAC-based one-time password, and this is event-driven and changes when a specific event occurs. There are advantages over passwords, as tokens code changes frequently, so attackers would have to crack the code within a very limited time. Users may not know if the password has been stolen. So if a token is stolen, it becomes obvious, and then again you disable the account. Cards. A smart card containing an integrated circuit, a chip. Contact pad will allow the electronic access to the chip. Very common, like a CAT card or a common access card, typically used in the military. That's one type of card that's used. We can have what's called a smart card standard covering all the U.S. government employees and their PIV, or personal identification verification standard. We could also have cell phones. And this is increasingly replacing tokens and cards, as a code can be sent to a user's cell phone through an app or through a message. Standard biometrics, that's going to be things like fingerprints. There are disadvantages. Cost of the hardware, time for implementation, and there is a cognitive biometric, which relates to the perception, thought process, and the understanding for the users. Basically easy for the users to remember because it's based on life experience. So there are pros and cons. Cognitive biometrics could be difficult for an attacker to pretend to have. Picture gesture authentication, or PGAs. You see that very common within banking systems now. The user reproduces gestures seen on a previous photograph, or a user predefines a photograph and is prompted with the photograph when trying to log in, and so the appropriate user would have to then select the correct photograph. So within the cognitive biometrics, identifying specific faces, for example, here's a list of 10 faces. Click the ones that are frowny. Here's an example. Behavioral biometrics authenticates by normal actions the user performs, like a keystroke dynamic or some type of voice recognition. Within the keystroke dynamics, attempts will recognize user typing rhythms. Uses two types of unique typing variables, dwell timing and flight time. Dwell timing is time it takes to press and release a key, where flight time is the time between keystrokes. It's said that each user has very unique dwell time and flight time. Here we have our variations. Basically, we have behavioral biometrics, what is been found to be us, and then the attacker might have a variation of inputting things like a username and password, and so our approved template versus an attacker's template, they will probably not be the same. Voice recognition, again they're looking at several characters that make each of the user's voices unique. Voice templates can be created, so it's difficult for an attacker to authenticate using a recorded of a user's voice. Phonetic candidacies for putting words together as part of real speech patterns. We also have things like a geolocation, identify location. Alright, moving on to single sign-on. Single sign-on allows for identity management, basically using a single authentication credential shared across multiple platforms, resources, or multiple networks. Often it's called a federated identity management, or FIM, when using networks that are owned by different organizations. So a single sign-on will hold promise to reduce burden of username and passwords. Very commonly, SSOs, or single sign-ons, are like a Microsoft account, or OpenID, or OAuth type account. Introduced in late 90s, the .NET Passport. This was designed as a single sign-on for web commerce. Today it's known as the Microsoft account. Authentication process, basically the user will enter a username and password. Once authenticated, it gives the user a time-limited global cookie that's stored on the computer with an encrypted tag that you can use to verify your identity. The authentication process, that tag will be sent to websites the user wants to log into. If the website uses the ID tag, it'll use it for authentication, and the website stores encrypted time-limited local cookies on the computer. Again, there are both global and local cookies is the basis for this Microsoft account, and the cookies are erased when the user logs out. The OpenID is a decentralized open source FIM. It doesn't require specific software. It is URL based. OpenID provides a means to provide a user's own means to prove a user owns the URL. Authentication process, basically the user will go to a free site and be given an OpenID account for like a me.myopenid.com. That will be your unique ID, your unique URL and ID, and that will allow you to verify that you are you. Users will visit the web commerce or other sites and sign into them using their own OpenID. The site redirects the user to the myopenid.com where they enter their password to authenticate. The My OpenID will send it back to the website, now authenticating. Though a very big weakness here is it relies heavily on DNS, which has their own weaknesses, and not considered strong enough for most banking and e-commerce websites. OpenAuth or Open Authorization permits users to share resources stored on one site with a second site without forwarding authentication credentials. This basically allows streaming or streamingless data sharing among multiple sites. It does rely on token credentials, which replaces the need to transfer users' username and passwords, as the token are for specific resources on site, and again for a very limited time. Managing those account passwords can be done by setting password rules. Typically, they're too cumbersome to manage a user-by-user basis, and there are security flaws here. The preferred approach is assigning privileges based off of groups. You can see this by Microsoft Windows group password settings, password policies, and account lockout policies, such as things like password age, minimum length, complexity, password history, account lockout thresholds and duration, and even a reset account lockout counter time. We have a transitive trust, which is a two-way relationship that is automatically created between a parent and child domain in a Microsoft Active Directory forest. And when a new domain is created, it shares resources with its parent domain. By default, it trusts its parents. And that is actually the end of this chapter. If you have any questions, please reach out and let me know. Thank you.